In this video, we're going to cover curves defined by parametric equations. So first we have a diagram. It says, suppose a particle moves along the curve C shown below. So you can see that you have arrows on your curve, and that indicates the direction. And then also, here's one point, for example, it's x comma y, but it's equal to f of t and g of t. It says it is not possible to describe the curve C by an equation of the form y equals f of x because the curve is not a function. However, we can think of the x and y coordinates of the particle as functions of a third variable, t, often corresponding to time. So we can represent them as x equals f of t and y equals g of t. And next we have a definition. It says, suppose x and y are both given as functions of a third variable t called a parameter by the equations x equals f of t and y equals g of t, called parametric equations. So t is the parameter, and then these are our parametric equations. Then we have each value of t determines a point xy, which can be plotted in a coordinate plane. As t varies, the point xy, or f of t, g of t, varies and traces out a parametric curve c. This example says, consider the parametric equations x equals t squared, y equals t cubed, and t is in between -2 and 2 inclusive. Part A says, sketch the curve, use the parametric equations to plot points and indicate direction. So first I included a chart. It's a txy chart, and we have that t is between -2 and 2. So in our chart, we'll start with t is -2, and then we'll go -1, 0, 1, and then 2. So we're going to take these values for t, and we're going to plug them in right here for t, and that will give us our corresponding value for x. We'll do the same thing. We'll plug all the values in for t here and get our corresponding values for y. So let's start with x. We'll take -2. -2 squared is +4. So again, when t is -2, we get 4 for x. So let's keep going with x. We're going to take t equals -1, plug it in right here. -1 squared is +1. So x is +1. Then t equals 0, we plug it in. 0 squared is 0. Then we take +1, plug it in. +1 squared is 1. And then we take 2, plug it in. 2 squared is 4. All right, so now we're going to do the same thing for y. We take t equals -2, plug it in. -2 cubed makes -8. So when t is -2, y equals -8. Next, t equals -1, we plug it in. -1 cubed is -1. So we get y is -1. Next, t equals 0, we plug it in and we get y equals 0. And then we'll plug in 1 and 2 in for t. So now we have all of our coordinate points, and now we're going to plot these over here on our xy axis. And again, remember, this is just a regular coordinate point. We have 4, -8. So when we plot this point, we get this point right here. Next, we have 1, -1. So that goes right here. Then we have 0, 0. Then we have 1, 1. So that's right there. And then finally, we have 4, 8. Next, we'll draw a curve connecting the points. And finally, we want to include arrows to indicate the direction in which we plotted the points. So again, when t was -2, we started at this point down here at 4, -8. Then when t is -1, we went to this point. Then we went to 0, 0, then 1, 1, and then 4, 8. So you can see I drew arrows indicating that we moved in this direction. All right, perfect. So there's our final graph. Part B says eliminate the parameter to find a Cartesian equation of the curve. And I have a note over here. It says solve one equation for t, and if possible, substitute into the other equation. So again, for our parametric equations, we have x equals t squared, and we have y equals t cubed. So we're going to solve one of these equations for t. Let's go ahead and start with this x equals t squared. And to solve for t, we're going to square root both sides. So I just flipped this around and wrote t squared equals x. To solve for t, we take the square root of both sides and then also include a plus or minus. So we get that t is equal to plus or minus the square root of x. And I'm just going to rewrite this as plus or minus x to the 1/2. And now, since t is equal to plus or minus x to the 1/2, we can take that and plug it into the other equation. So our other equation is y equals t to the 3rd. So we're going to take this expression and substitute it in for t. So we have plus or minus x to the 1/2 being raised to the power of 3. So when you have x to the 1/2 raised to the power of 3, we can multiply those powers and we get 3/2. And again, since this is odd, when you take a positive and cube it, it's still positive, but if you take a negative and cube it, it's also negative. So that's why you get plus or minus x to the 3/2. So now this is our Cartesian equation of the curve, because now we have an equation with x and y. And finally, if we were to plug this into a graphing calculator, you would do y equals positive x to the 3/2, and that would give you this part of the curve. And then you would also do another y equals negative x to the 3/2, which reflects across the x-axis and gives us this bottom half of the graph. This example says, given the parametric equations x equals 4 cosine of theta, y equals 5 sine of theta, and theta is in between negative pi over 2 and positive pi over 2 inclusive. Part A says eliminate the parameter to find a Cartesian equation of the curve. And I have a note over here. It says to eliminate the parameter, we're going to use the Pythagorean trig identity, sine squared of theta plus cosine squared of theta equals 1. So in order to use this, what we need to do is we need to first isolate cosine theta and sine theta. So to isolate cosine theta, we're going to divide both sides by 4. So we end up getting that cosine of theta equals x divided by 4. We're going to do the same thing over here. We're going to divide both sides by 5. So we end up getting that sine of theta equals y divided by 5. So next we're trying to use the trig identity where sine squared of theta plus cosine squared of theta equals 1. That means we need to get cosine squared and sine squared. So the way we're going to do that is we're going to square both sides of both equations. So for our first equation, we're squaring both sides, and we're going to do the same over here. So this becomes cosine squared of theta, and over here on the right, you end up getting x squared over 16, and then we're going to do the same over here. So when we square this, we get sine squared of theta, and then over here, we're going to get y squared over 25. So next, we're going to add these two equations together. So I'm going to take this equation and write it below this one. So we're kind of thinking of it as adding vertically. So here we have sine squared of theta plus cosine squared of theta, and this is going to be equal to the sum of these. So now you have this big equation. On this side, we have sine squared theta plus cosine squared theta, and then it's equal to x squared over 16 plus y squared over 25. And then finally, according to this trig identity, this left side is equal to 1. So we end up getting that x squared over 16 plus y squared over 25 equals 1. So here's our Cartesian equation of the curve, where again, you just have an equation with x and y. And you might recognize this equation from a previous math class of conics, where this is the equation of an ellipse with center 0, 0. And then the ellipse in the x direction goes out 4 in both directions, and then in the y direction from the center, it goes out 5 in both directions. Part B says sketch the curve indicating arrow direction as the parameter increases. When sketching the curve, consider the restrictions on the parameter. So if we look back up here, we have our parameter restrictions. Theta is between negative pi over 2 and positive pi over 2. So theta starts at negative pi over 2, so think about here's your x-axis and your y. We're starting down at negative pi over 2, and then as we move in this direction, we get to 0, and then we go up to pi over 2. So we have negative pi over 2, 0, and then pi over 2. And let's go ahead and plug these into our equation for x. So x is 4 cosine theta. First we plug in negative pi over 2 for theta, so cosine of negative pi over 2 is 0, and then 0 times 4 is 0. Next we're going to plug in 0 for theta, so cosine of 0 is 1, and 1 times 4 is 4. And then finally we'll plug in pi over 2. So cosine of pi over 2 is 0, and 0 times 4 is 0. So here's our values for x, and now we'll do the same for y. So we'll plug in negative pi over 2, 0, and then pi over 2 to find our values for y. So first we plug in negative pi over 2, so sine of negative pi over 2 is going to be negative 1, and negative 1 times 5 is negative 5. So we get y equals negative 5. Now we're going to plug in 0, so sine of 0 is 0, and 0 times 5 is 0, and then we're going to plug in pi over 2. So sine of pi over 2 is 1, and 1 times 5 is 5. All right, let's go ahead and plot these points over here. So first we have 0, negative 5, so 0, negative 5 will go there. Next we have 4, 0, so 4 comma 0 is right there. And then we have 0, 5, so 0 up 5 is right there. Okay, so here's our curve, and we want to include arrows to indicate direction. So first, when theta is negative pi over 2, we have the point 0, negative 5, so that's right here. And then when theta is 0, we go to the point 4, 0. So it's going in this direction. And then we go to pi over 2 and to the point 0, 5. So that brings us up here. So our arrows go in this direction. And it works out great because you can see you have an ellipse. The center is at 0, 0. In the x direction, you're going out 4, and then you're going out 5 in the y direction. And we only have the right half of the ellipse because theta is from negative pi over 2 to positive pi over 2. This example says, describe the motion of a particle with position xy as t varies in the given interval. We have x equals 2 plus cosine of t, y equals 3 plus sine of t, and then t is between 0 and 2 pi inclusive. So we're going to treat this problem very similarly to the last one. We want to isolate the cosine and the sine. So to isolate the cosine, we're going to subtract 2 from both sides. Over here, to isolate the sine, we're going to subtract 3 from both sides. Next, we're going to square both sides of the equations. And then I'm going to rewrite this as cosine squared of t. And I'm going to leave this as quantity squared. I'm going to do the same thing over here. I'm going to rewrite this as sine squared of t. And then leave this as quantity squared. All right, and next we're going to bring this equation down here so that we can add the two equations. And again, we're adding the equations vertically, so on this left side we're going to have sine squared of t plus cosine squared of t. And then on the right side we're going to have these two expressions, so we'll have x minus 2 quantity squared plus y minus 3 quantity squared. And then at this point we have over here the Pythagorean trig identity that sine squared of t plus cosine squared of t equals 1. So we can set this part of the equation equal to 1. So here's our final Cartesian equation. We have x minus 2 quantity squared plus y minus 3 quantity squared equals 1. So you're probably noticing that this is an equation with center 2, 3, and radius 1. And that's great, so we could plot that right now. But we also want to know the motion of the particle and the direction in which it's moving. And we're also given that t goes from 0 to 2 pi. So you can see that I set up a txy chart here. We have t starts at 0, then goes pi over 2, then pi, then 3 pi over 2, and then 2 pi. So we're going to take these values and plug them in for t, and then we'll get our corresponding values for x and y. So first, t equals 0, cosine of 0 is 1, 1 plus 2 makes 3. Next, plugging in pi over 2, cosine of pi over 2 is 0, so 0 plus 2 is 2. Then we have pi, cosine of pi is negative 1, so 2 minus 1 is 1. And then 3 pi over 2, cosine of 3 pi over 2 is 0, 2 plus 0 is 2. And when t is 2 pi, we get cosine of 2 pi is 1, and 1 plus 2 is 3. Now for the y's, t equals 0, we get sine of 0 is 0, and 3 plus 0 is 3. Pi over 2, sine of pi over 2 is 1, and 1 plus 3 is 4. And then pi, sine of pi is 0, so we get 3. And then sine of 3 pi over 2 is negative 1, so negative 1 and 3 is going to make 2. And finally, sine of 2 pi is 0, and 0 plus 3 is 3. Okay, so let's go ahead and plot these points. So first we have 3, 3, then we have 2, 4, and then 1, 3, and then 2, 2, and then back to 3, 3. And the first point was right here at 3, 3, then it went up to 2, 4, then 1, 3, then 2, 2, and then back to 3, 3. So there's the arrows that indicate the direction. And finally it says to describe the motion of a particle with this position as t varies in the given interval. Here's our description. It says the particle moves counterclockwise about a circle centered at 2, 3, making one revolution starting and ending at the point 3, 3. Alright guys, thanks so much for watching, and please subscribe to my YouTube channel, Math with Yosh, and hit the like button. I appreciate it.